Hello, my name is Rakesh Kahan. I'm a student of University Tenaga Nasional, and this is my assignment for failure analysis and design. So our assignment is to talk about the fail-safe versus safe life design, and I've chosen the oil and gas industry to investigate. So safe life is a period of time in which a piece of equipment is deemed to have a very low probability of failure. So in other words, this is the period of time in which this device will not fail. And we can't say for sure that it will not fail because everything has its own probabilities, but it has a very, very low chance of failure. So it's also known as safety by retirement, as in before it fails, it's already retired. This philosophy is operated during service life. Meanwhile, fail-safe is a design that incorporates various techniques to mitigate losses due to system or component failures. In other words, it's a redundancy and backup. So fail-safe is generally regarded as a design philosophy used after service life. So why would we have a safe life design philosophy? So in oil and gas, there are so many systems at large scale that a lot of things can go wrong. At the same time, the cost to actually repair these equipments and the procedures to repair these equipments are very, very difficult and also very costly. So therefore, these equipments are designed to actually last a certain period of time in which probability of them failing is very, very low. So then after this period of time, let's say 10 years, this equipment will just be automatically replaced instead of fixed. So these systems are usually systems in which when failure occurs, it could cause severe damage to life and or property. Initially, it can seem like we're wasting materials by retiring equipment that still can be used but has finished its safe life. But in the long term, it can actually save a lot of money and lives because all it takes is one system to go wrong in a drastic way to cause a really, really severe accident, as you'll see at the end of the presentation. So these are some examples of safe life design. So firstly, we have pressure vessels. They're designed to hold fluids at very high pressures. Because of the kind of stresses these vessels go through, they are usually retired after their safe life. It also depends on the state of their operation, because some of them hold fluids for a certain pressure constantly. Some of them are pressurized and depressurized on and off and on and off, and that can cause more stress, which will reduce their safe life. Next are pipelines. These are pipelines carrying oil and gas from the offshore platforms to onshore, as well as to use in midstream and downstream applications. These have to last a really, really long time because it's very, very difficult to repair them, especially if they're undersea or underground, which is usually the case. So therefore, these things can usually last maybe 40, 50 years before they actually have to be replaced. Compressors and pumps, I put them together because they're quite similar equipment in oil and gas. This is a between bearing multi-stage compressor. Equipments like these have already gone through a lot of research and development to ensure their safe life is truly safe. And lastly, for this example, we have fire water systems. These systems are extremely crucial to the safety of the personnel on board offshore stations as well as any onshore stations as well. So usually these pumps as well as pipelines are overbuilt to ensure that they can last through explosions as well as fire. So now, why do we have fail-safe in oil and gas if we already have safe life design? Even in safe life design, there's always something that can go wrong. It's a low probability, but there are things that can malfunction. So therefore, we need redundancy for critical equipment, because if these equipments fail, it can incur an extreme cost to the company as well as to the environment. So first, we have a relief valve. It's usually used for pressure vessels as well as pipelines. Once the pressure of a pipeline or a pressure vessel has exceeded the amount that's deemed safe, these things take over and release pressure. Next, we also have circuit breakers for all the electrical components. When equipment fails or trips, it'll actually trip the circuit breaker instead of failing all the other equipment. There's also secondary containment systems. So these are storage vessels here, and this is a secondary containment system. So if these things leak, this containment will actually contain it instead of allowing it to seep into the environment. And finally, we have a blowout preventer. So when the platform drills for oil and gas deep below the sea, the wells that they drill into that contain the oil and gas actually contain them at extremely high pressure. So if you don't have this device, a blowout can occur. What happens is the oil and gas escape at very, very high pressures and the situation cannot be controlled. So this device is installed at the exit of the well to control the pressure as well as to shut off the flow in the case of an emergency. So this is an example of what happens when safe life procedures are not followed strictly and fail-safe devices themselves are not maintained to provide a safe backup in the case of failures. This is Deepwater Horizon. To summarize the disaster, the crew were drilling for oil. It was detected that the flow of gas and oil was way more than expected and the ship would not be able to accommodate for it. So therefore, the blowout preventer was activated. However, it failed. When the blowout preventer failed, they went for the last failsafe, which is not pictured here, but it's a blind shear ram. What it does is it physically cuts the pipeline. However, this equipment also failed. So this shows what happens when safe life measures as well as fail-safe measures are not taken seriously and it can cause a disaster such as this. So this is why fail-safe and safe life is extremely important in oil and gas as well as many other industries. If taken seriously, it can save the company lots of money, save the environment, as well as save many lives. Thank you for listening to my TED Talk. Have a nice day.